Now that we've studied the graphs of sine and cosine, it's time to look at the graph of tangent. Now tangent is just the ratio of sine and cosine. So it's the next logical step. Now, in our study of trig, typically we go back to the unit circle. When we want to study the trig functions, a good place to start is at the unit circle. And our study of tangent is going to be no exception. Now, the thought process goes something like this. In trying to determine what the graph of tangent looks like, we remember, well, tangent is sine over cosine. And once we recall that, certain things become clear to us. For example, since cosine is in the denominator, we know that wherever cosine is 0, tangent will be undefined. There's no question about that. So that's going to happen at two places. That's going to happen at pi over 2 and at 3 pi over 2. Now, not just those two places, but all angles coterminal to that. So, if we're at pi over 2 and we go around the circle, as many coterminal angles as there are, that's how many places tangent is undefined. Coterminal angles to pi over 2 as well as 3 pi over 2. All coterminal angles to those two angles are give you an undefined tangent. Now, you'll notice that if you're here at pi over 2 and you add pi to it, you get to a place where tangent is undefined, 3 pi over 2. Then if you add pi to that, you're right back at a place where tangent is undefined. Add pi to that, you're right back to a place where tangent is undefined. So here's the thing. Tangent is undefined at pi over 2 and all integral multiples of pi that you add to pi over 2. So for example, if you start off with pi over 2 and you subtract 3 pi, well, you're at a place where tangent is undefined. Any integral multiple of pi that you add to pi over 2, you get a place where tangent is undefined. So we want to keep that in mind. Then we want to also note that wherever sine is equal to 0, that's where tangent is equal to 0. And that occurs at two places on the unit circle at first, at 2 pi, well, at 0 and at 2 pi. So two places there. And then over here at pi and 180. So at 0, pi, and 2 pi. And likewise, you notice that if we continue around the circle from 2 pi, we go over here at 3 pi, it's also 0. Go around 4 pi, it's 0. As many times as we go around the circle, we land on multiples of pi, and when we do, we find that we have a place where sine is equal to 0. So tangent is equal to 0 at all integral multiples of pi. So 1, 2, 3, 4, 5, 6, 7 pi. All those integral multiples of pi, negative 2 pi, negative 3 pi, and so forth. That's where you have tangent 0. Now what we want to do is take that information and put it on an axis. I'll start off just drawing an axis and labeling negative pi and pi. Now, what you're looking at now is you're looking at places where, you're looking at three places here where tangent is going to cross the x-axis. In other words, where tangent is equal to 0. Tangent is equal to 0 at 0, because sine is equal to 0 there. Tangent is equal to 0 at pi, and it's equal to 0 at negative pi. So we're looking at both sides of this y-axis, to the left and to the right. So we have labeled the places where tangent is equal to 0. Now let's look at the angles where tangent is undefined, certainly at pi over 2 and negative pi over 2, but also at 3 pi over 2 and negative 3 pi over 2. Now these are places where tangent has vertical asymptotes. Vertical asymptotes exist at these places where tangent is undefined. So I've drawn the vertical asymptotes, and then up here at the top I've placed just an XY axis, and I've labeled these quadrants with either pluses or minuses. Now what that is, it's an indication of the sign of tangent in those quadrants. Now remember, tangent is sine over cosine. So for example, if you look here at quadrant 1, quadrant 1 is positive because sine is positive there and cosine is positive. Quadrant 2, on the other hand, is negative because sine is positive but cosine is negative. Quadrant 3 is positive because sine and cosine are both negative. And then quadrant 4 is negative because sine is negative and cosine is positive. Now, if you look down here from negative pi over 2 to pi over 2, that corresponds to the first and fourth quadrant. So from 0 to pi over 2, that's the first quadrant, and tangent is going to be positive there. Now from 0 to negative pi over 2, that corresponds to the fourth quadrant, and tangent is negative there. So if we were to look at the graph of tangent in that region, that's what it would look like. Now, let's look at the next quadrant, or the next region, and that is the region between negative pi over 2 and negative 3 pi over 2. Now you notice that, once again, between negative pi over 2 and negative pi, you're in the third quadrant, and in the third quadrant, tangent is positive. Between negative pi and negative 3 pi over 2, you're in the second quadrant where tangent is negative. So there's what the graph looks like there. Now, if you venture over to this region between pi over 2 and 3 pi over 2, what we have is a very similar situation to what we just graphed. We're still dealing with these two regions here, the second and the third quadrant. Because notice, pi over 2 to pi, that's the second quadrant, and pi to 3 pi over 2 is the third quadrant. So it's going to look very much like the previous graph, and there you have it. Now this pattern continues on. We could continue on, adding to these numbers, and if you add another pi over here, you could have 2 pi and then get some more asymptotes, and you would see that this tangent graph, of course, continues forever. Okay. Now, let's just make some observations about tangent. First of all, the domain of tangent, as we've stated earlier, is theta can equal any real number except pi over 2 plus any integral multiple of pi. So that's the domain. Where you have that, where you have pi over 2 plus an integral multiple of pi, that's where you have an asymptote. So asymptotes occur there. Now the range, negative infinity to infinity. There's no restriction. Tangent goes from negative infinity to infinity. Now the period. You can see clearly that tangent makes a complete cycle. It does everything it's going to do as a graph between negative pi over 2 and pi over 2, between pi over 2 and 3 pi over 2. In other words, this distance here is pi. So we say that the period of tangent is pi.